Hey everyone, and welcome back for another deep dive. Buckle up, because today we're taking on a topic that is really uh, kind of bending my brain a little bit, honestly. We're talking about cosmic strings.
Yeah, this is going to be a fun one.
You listeners have sent in some incredible articles and research about this, so we're going to be exploring cosmic strings
Hmm.
and how they might tie into string theory, gravitational waves, and, maybe even time travel.
Time travel, oh my.
But let's get right into it. So, just to set the stage, string theory is basically this idea that, and I'm sure many of you already know this, but the universe isn't made of particles, but instead it's made of these tiny vibrating strings.
Right? Tell
Yes?
me that. It's a pretty radical concept when you think about it. Instead of picturing, little tiny billiard balls bouncing around, we should be thinking of like these infinitesimally small vibrating strings making up everything.
So all those atoms and quarks and leptons that we hear about are actually just vibrations.
Pretty much. And the implications of that are just massive. Like imagine if every particle, from the smallest atom to the largest star, is just a different kind of vibration of these strings.
So the universe is like a giant symphony.
Exactly.
Well, I like that. I'm a very musical person. But hold on. How do we go from these teeny tiny strings to the cosmic-sized strings?
Right. Well, here's where things get super interesting. So, some physicists believe that in the early universe, like right after the Big Bang, some of those little tiny strings could have been stretched out.
Stretched. How?
Well, because of the rapid expansion, right? So, they could have
Mhm.
gotten stretched to these just enormous lengths, like think spanning vast distances across the universe.
Oh, wow, I see. So we're talking about strings that could stretch from one end of the observable universe to the other.
Potentially, yeah. And those are the cosmic strings we're talking about.
I'm trying to picture it. So like these incredibly thin but super dense strings just crisscrossing the universe.
Yeah, something like that.
That's kind of hard to even wrap my head around. But if they are out there, how could we ever hope to find them? They're like smaller than an atom, right?
Well, they're thin, that's for sure.
Yeah.
But they could also be incredibly long, and that means they would have a lot of mass. And mass means gravity.
Ah, okay.
So one way to find them is to look for their effects on light.
What do you mean?
Well, because they have so much gravity, cosmic strings warp the fabric of space-time around them, causing light to bend, it travels along these curved paths. And so we can potentially detect them by looking for those distortions.
That's kind of like the gravitational lensing that we see around black holes and galaxies.
Exactly. It's the same basic principle, but with a bit of a unique twist.
So both galaxies and cosmic strings can cause lensing, but the light bends differently.
You got it. So galaxies can create multiple images of a distant object, too. But the images produced by cosmic strings, those would look really different. They would appear as these, like, perfectly clean, parallel, duplicate images.
Ah, okay. So it's not just any old lensing. It's a very specific type of lensing. And scientists are out there right now, like actively searching for these perfect parallel images.
Yep, exactly. That's one of the ways they're trying to find evidence of cosmic strings.
It seems incredibly difficult.
It is. It's like finding a needle in a cosmic haystack. But there have been some interesting observations that could potentially be explained by cosmic strings. But as with all things in science, we need more data, more research to say for sure.
Okay, so this is all pretty mind-blowing, I'm not going to lie. But it makes me wonder, with all this talk about bending space-time, is there any connection to the idea of time travel here?
Well, that's where it gets really, really interesting.
Okay, I'm listening.
So there's actually a theoretical paper out there, and it suggests that if two cosmic strings, right, were aligned in a very specific way, and here's the kicker, you could somehow fly a spacecraft around them just right, it might, and I stress might, be possible to travel back in time.
Hold on, time travel.
Yeah.
Like Back to the Future style.
Huh, yeah. Kind of like that. It sounds like pure science fiction.
It really does.
But Einstein's theory of general relativity, which is what describes gravity and the curvature of space-time, doesn't technically rule out time travel.
Okay, so it's not impossible, but...
But, and this is a big but, there would be some pretty massive practical hurdles to overcome.
Like what?
Well, there are all sorts of paradoxes and quantum effects to consider. We're talking about like messing with the very fabric of reality here. It gets pretty complicated, and we are nowhere near actually doing it, even if it is theoretically possible.
Right, that makes sense. So time travel with cosmic strings is still firmly in the realm of theoretical physics, not something we're going to be doing next Tuesday.
Right. But the fact that it's even theoretically possible, that's pretty amazing, right? It speaks to how strange and powerful these cosmic strings could be.
I mean, yeah, I guess if you can bend space-time enough, who knows what's possible?
Exactly.
It's all about keeping an open mind and exploring these possibilities.
Exactly.
Are there any other wild implications that cosmic strings could have?
Well, just confirming their existence would be a huge deal for physics. Like, it would give a lot of support for string theory itself, which is still a very controversial idea.
Right, because as of now, string theory is just a theory. No pun intended.
Right, exactly. And beyond that, cosmic strings could help us with some of the biggest mysteries out there. Like, what is dark matter? What is dark energy?
Oh yeah, those are big ones.
Really big. And the way cosmic strings interact with the universe could give us some clues.
You know, it's times like this when I really feel like we're on the verge of, uncovering some truly fundamental truths about the universe. Like maybe we're just scratching the surface.
I feel that way too sometimes. It's what keeps me going as a scientist.
Well, this has been an absolutely incredible deep dive. I've learned so much, and I hope you all have too. And, it makes you think, what other mind-blowing implications might be out there? What other secrets of the universe are just waiting to be discovered? Keep those questions swirling. And until next time, happy deep diving.